Right, okay guys, today I'm just going to talk you through an example of working out the delta H formation of any substance. You'll be using the same method, so follow this procedure. And in this situation it says we have a formula, then it's asking you to work out the standard enthalpy of formation of but 1,3-diene. I'm going to tell you how to work this out. The first thing you need to look at is what data is given. So first steps would be inspect this section here, okay? So as I look, everything is burning in oxygen. This means it's a combustion reaction. So we established these values, okay, are all for combustion. Remember that thing, delta H? See? So it's combustion values. Now, the first step is I want to create a triangle to work out what the value is. So I want to write out the equation. So 4 carbons plus 3 hydrogens gives us this alkene, C4H6. Remember, this is but 1,3-diene. So it's combustion, that means everything's burning in oxygen. So there's 4 carbons, okay? So it's going to be 4 CO2 plus the only other constituent is hydrogen, and there's 3 there. So if we write out 3 H2O, now we'll see everything balances. Now what we want to do is we want to point all the arrows down. Because it's combustion, we're pointing all the arrows down up first. Right, now what I want you to do is write down the values from this data table here, this data table of what we have, and multiply by coefficients. So I want to change color so you can see what I'm talking about here. Let's go green. So 4 CO2s, 1 CO2 is minus 394. Okay, and remember we said there's 4, so I'm going to put a 4 there. And then we've got 3 H2O. So 1 H2O is minus 286. And remember, we said there's 3 because of the coefficient. So that's multiplied by 3. Let's just put multiplied as well, so it's pretty clear here. Okay, and then the but 1,3-diene has a value of minus 2,542. Now, I'm just going to change color again. I'm going to go blue this time. Okay, now here's the key step. We want a route to the products. Now, these 2 arrows are pointing downwards, so we leave them as they are, and we're going to change this arrow here and change it to point upwards to get the products. So that's the rule. When it's combustion, you leave the reactants as they are and you flip the arrow. That's the way I do it. Now let's have a look. So I'm rubbing this out and I'm flipping. Now I've flipped, this negative value becomes positive, and that is the only change we do. After this, all we're doing is adding all the values together. So we get a calculator, we do 4 times minus 394 plus 3 times minus 286 plus 2542. Now, if we do this in a calculator, you'll see you will get a value. I'm just going to calculate this now, so I'm putting it in the calculator, and this gives you guys an opportunity to also have a try. So 4 times minus 394 equals plus 3 times minus 286 equals plus 2542, which equals the value is plus 108 kilojoules per mole. Okay, and that's endothermic. Now there's your answer. So I'm just going to summarize this. This is for you guys who requested this in the feedback form. So you look at the values, you see it's combustion, you write out the combustion options, and then add the values, and then change one of the arrows. Remember, they're all pointing down at first. You change one to go to the products, add them all up. That's where you get your answer. I hope this makes sense. I'm going to post this for you guys now.